Okay, I hope I'm audible to all students who are attending this lecture of Intermediate Macroeconomics Part 1. We continue with our lectures on money demand theory. Okay, and the book I prefer to follow for my lectures on money demand theory, this is chapter 14 of the book Macroeconomics by Branson. Now, all students can recall that in the previous lecture of money demand theory, we had done a revision of the transactions demand for money. We said that transactions demand for money is a function of the interest rate and the level of income. Okay, and we had said in the previous lecture that the demand for money shares a negative relationship with interest rate. So del M by del R is negative, because when interest rate goes up, holding bonds becomes more attractive because bonds pay you interest unlike money. So when interest rate goes up, opportunity cost of holding money goes up. So demand for money falls. So del M by del R is negative. On the other hand, del M by del Y is positive because when income goes up, you start demanding more money to make transactions of buying goods and services. So we can say that demand for money shares a positive relationship with income and a negative relationship with the interest rate in the economy. Okay, then in the previous lecture we had said that the individual has a given amount of liquid wealth W. Okay, and this wealth is not going to change for the period under discussion. That means we are assuming that the wealth is constant at any one particular point of time, and the individual has to decide how much of this liquid wealth to be allocated to each of the two kind of assets. So in the last lecture we saw that you can hold your wealth either in the form of money, which is nothing but currency plus demand deposits, or you can also hold your wealth in the form of bonds. The good thing with bonds is that unlike money, bonds are going to give you interest. But the limitation is that bonds bear a liquidity risk. That means you might buy a bond today at a higher price, and when you want to sell the bond, if at that time the price of bond in the market falls, then you will be forced to sell the bond at a lower price than the price at which you bought. So you earn a capital loss on the bond. That is the risk associated with holding your wealth in the form of bonds. Okay, then in the previous lecture, we had started our discussion of the regressive expectation model. Okay, so on the whiteboard, I am quickly revising the equations we had done in the previous lecture concerning the regressive expectation model. Let's quickly revise the equations of the regressive expectation model. Although this model was not over yet, we had just started this model in the previous lecture. Today, we are going to go into more depth of it. Okay, so all students can recall W denotes the wealth. You can hold it in two forms, money and bonds. Okay, in the previous lecture, we had calculated the expected return on the bond. So there are two sources of return on the bond. One source was nothing but the bond's yield. We had done in the previous lecture, which we had calculated. Bond's yield, okay, it is a fixed percentage of the bond's face value. Okay, and bond's yield we denote by Y. Okay, and then we have the potential capital gain. Potential capital gain, that is an increase, that is an increase in the price of bond from the time the bond is bought to the time the bond is sold. So we had taken examples in the previous lecture. Okay, suppose I buy a bond by paying a price of $100 today, and suppose when I sell the bond in the market, it is sold for $110. So I have made a clear capital gain of $10 on the bond. Basically, it's nothing but the difference between the price at which I sell the bond minus the price at which I bought the bond initially. Okay. Now all students can recall that R used to denote what? R denotes the market rate of return on the bond. R denotes the market rate of return on the bond. And in the previous lecture, we calculated the expression for R. R is nothing but the yield of the bond divided by the price you pay for the bond, where Y denotes the yield, which is a fixed percentage of the face value of the bond. Remember, face value of the bond is that value which the bond promises to pay you at maturity. Okay, and PB denotes the price of the bond. And I can also write this as, so my price of the bond is nothing but the yield divided by the market rate of it. So clearly, we learn that, what do we learn? Clearly, we learn that price of the bond shares inverse relationship with the market rate of return. That means when the market rate of return goes up, price of the bond is going to fall. And when the market rate of return goes down, price of the bond is going to rise. We had done some examples also in the previous lecture. Students can revise the previous lecture also again. Okay. And then we had calculated the expected percentage capital gain, because till now we have not calculated the expression for potential capital gain. We did this in the last lecture. I'm going to revise it again. How do we derive the expression for potential capital gain? So if I erase the initial part, we can quickly derive the expression for the potential capital gain. So I can say the expected percentage capital gain, which is G, is equal to the expected price at which I plan to sell the bond minus the actual price at which I bought the bond divided by the actual price at which I bought the bond. The reason why we have expected here is because I don't know the price at which I will be selling the bond in the future. All I know is the expected price, PBE. PBE is the price at which I expect to sell the bond in the future. Minus PB is the actual price at which I have bought the bond. Okay. And now all students can see that since actual price of the bond is nothing but the yield divided by the rate of return from the bottom equation, therefore expected price is nothing but the yield divided by the expected market rate of return. Remember guys, your yield is constant. Why? Because yield is a fixed percentage of your face value. Yield is not changing. So the price at which I expect to sell the bond in the future depends upon the expected market rate of return on bond in the future. Okay, so now I can put these expressions to calculate the expected percentage capital gain. So I erase this part. I erase this particular part, and we can put the value of PB and PBE in our expression G. So I can write, therefore G is equal to PBE is Y by RE minus PB is Y by R divided by PB is Y by R. I take Y common. Y cancels. R comes in the numerator. So my G is nothing but R upon RE minus R divided by R is 1. This is my expression for expected percentage capital gain on the bond. You can clearly see it depends upon the market rate of return and the expected market rate of return, R and RE. Okay, and then in the previous lecture, we had also calculated the total rate of return on the bond. Okay, so erasing this particular part off, we can quickly write the total rate of return on the bond as follows. So therefore, define the total rate of return on the bond. Define the total rate of return on the bond as the term E, which is equal to the market rate of return plus the expected percentage capital gain on the bond. So E is equal to R plus G. What is R, guys? R is itself plus what is G? R upon RE minus 1. This is nothing but my total rate of return on the bond, which was calculated in the previous lecture also. I just took it up for revision in this lecture. Now, what are we doing in today's lecture? Okay, so we now look at individuals' demand for money under regressive expectation model. Okay, so let's look at individuals' demand for money function, because ultimately our objective is to derive the demand for money under the regressive expectation model. So individuals' demand for money under regressive expectation model, REF. Okay, so now if I quickly write, guys, the total expected return on the bond is how much? Total expected return on the bond is equal to E, which we have calculated, and return from money is how much? Return on money is equal to 0. Money is not giving you any return. You are just holding money purely for transaction purposes. Remember, till now we have not talked about speculative purpose of holding money or precautionary purpose of holding money. Till now we are only concerned with money as far as it helps us in making transactions of buying goods and services. So money is not giving us any return. It is only helping us to buy goods and services. That means making transactions. So return on money is 0, but return on bonds, they have calculated it's nothing but E. Okay. Now, the asset holder will, case 1, put all his liquid wealth. He will put all his liquid wealth in bonds if the expected rate of return on bond is more than the return on money. That means E is greater than 0. If the total expected return on bond exceeds the return on money, the bondholder is going to put all his wealth in the form of bonds, because money and bonds are close substitutes. Okay. Case 2, put all his liquid wealth. Liquid wealth is denoted by W. Okay. Put all his liquid wealth, which is W, in money if the expected return on bond is less than 0. If E is less than 0, that means the bondholder is going to put all his liquid wealth in money. And case 3 will be indifferent between holding his liquid wealth in money and bonds if E is exactly equal to 0. If the total expected return on bond exactly equals the return on money, in that particular case, the asset holder is going to be indifferent between holding its liquid wealth in the form of money or in the form of bonds. So what will be the composition of liquid wealth in terms of money and bonds depends on the comparison of E with 0. If E is greater than 0, that means total expected return on bond exceeds the return on money. So all the liquid wealth will be in the form of bonds. If E is less than 0, it means the expected return on bonds is less than the return on money. So all the liquid wealth will be in the form of money. If E is exactly equal to 0, well, in that particular case, you can expect the asset holder to toss a coin. and decide whether he should put all his liquid wealth in money or in bonds. He's indifferent in that case. Okay, so now let's, in order to derive the demand curve, money demand curve, let's move into the depth. Now, a very important assumption we have, under the regressive expectation model, each individual is assumed to have an expected interest rate. An expected interest rate RE, which corresponds to some long run average rate. Now we have to incorporate RE because all of us know we have derived the expression for E. Guys, what was E? E was nothing but R plus R upon RE minus 1. This was the expression for E which we had derived in the previous lecture, and we have even revised it today. Now, regressive expectation model says that every individual is going to have its own RE, and that RE is going to correspond to some long run average interest rate. Okay, and now how are the expectations regressive? Students must be wondering what is regressive. So you can look at this sentence which I am writing. If the actual interest rate falls, or I can say, let me correct myself, if the actual interest rate rises, above the long run average, then the individual expects the interest rate to fall in the future back to the long run average. That is, if suppose I denote the interest rate, the long run average interest rate as RL, just for simplicity. Okay, suppose the actual interest rate rises above the long run average, then in the future the individual is going to expect the interest rate to fall, so that in the future your actual becomes equal to the long run average. So guys, you can see that individual has regressive expectation. How regressive? Because actual interest rate went above the long run average. When the actual interest rate went above the long run average, if the individual would have had progressive expectation, he would have expected the interest rate to rise because actual went above the long run average. But he does not have progressive expectation. Progressive means you are moving in the same direction as the actual. Actual is rising, you expect the future interest rate also to rise. That is progressive. But in this particular case, individual is not having progressive, he is having regressive expectation. Regressive means when the actual rises above the long run average, he expects the actual to fall back to the long run average. He does not expect the interest rate to rise. When actual rises above the long run average, he simply expects that in the future this actual interest rate is going to fall back to the long run average. So it's regressive expectation, because you are not moving in the direction of the actual, you're moving against the direction of the actual. When the actual interest rate went up above the long run average, instead of expecting the interest rate to rise in the future, which was progressive, the individual expects the interest rate to fall in the future back to the long run average. That is regressive. Okay, so that is why we have the regressive expectation model, because individuals in this model, every individual is going to have its own RE value. So I can write it here. Every individual has its own expected interest rate RE. And this expected interest rate corresponds to some long run average rate. And immediately when the actual interest rate goes above the long run average, instead of expecting the interest rate to rise in the future, individuals expect the interest rate to fall in the future back to the long run average. Hence, their expectations are regressive in nature instead of progressive. Okay. Now, our job is what? Our job is to determine that critical interest rate which makes E equal to 0. Okay. So I am going to now erase some portion. Okay. So let me erase this particular portion now. Our job is now to see what should be the critical level of interest rate. Now, critical level of interest rate is that rate at which return from money is exactly equal to return from bond. Okay. So we now compute the critical interest rate. Call this critical interest rate by RC. Okay. We now compute the critical interest rate RC, that is that value of R that makes E equal to 0. Okay. Such that when R is greater than the critical interest rate, the individual holds all its liquid wealth in the form of bonds. Because guys, when R is exactly equal to the critical interest rate, E is equal to 0. When R is going to exceed the critical interest rate, the returns from holding bonds is going to go up. So individual is going to hold all its liquid wealth in the form of bonds, since E will be greater than 0. Similarly, when R is less than RC, that means when R falls below the critical interest rate, individuals hold all its liquid wealth. The individual holds all its liquid wealth in the form of money, since E is less than 0. When R was equal to RC, E was equal to 0. When R is below the critical level, that means returns from holding bonds is less than the returns from holding money. That means E is less than 0. So individual is going to hold all its wealth in the form of money. And I can then say that when R is exactly equal to RC, so I'm erasing this part. Erasing this particular part, I can say that when R is exactly equal to RC, it implies the individual is indifferent between holding its wealth. The individual is indifferent between holding its wealth in the form of money and bonds, in the form of money or bonds, since when R is equal to RC, E is equal to 0. So now, till now, we haven't derived the critical interest rate, but we are saying that there will exist some critical interest rate RC such that at the critical level of interest rate, E will be exactly equal to 0. When the actual exceeds the critical interest rate, E will be greater than 0. So individual is going to hold all its liquid wealth in the form of bonds. When the actual interest rate falls below the critical level, returns from holding bond is less than the returns from holding money. That means E is less than 0. So individual is going to hold all its liquid wealth in the form of money. And when the actual interest rate exactly equals the critical level, in this particular case, returns from holding bond exactly equals the returns from holding money. So the individual is indifferent between holding its wealth in the form of money or bonds. Now our job is to determine the expression for the critical interest rate. So let's now do that. Okay, so erasing this off. Let's now determine the critical interest rate, RC. So I'm erasing all this off. And quickly we can derive the critical interest rate, RC, which is going to be as follows. Okay, so I can write at R exactly equal to RC, E is equal to 0, which implies, what is E, guys? R plus R upon RE minus 1 is equal to 0, which implies 1 is equal to R plus R upon RE, which implies 1 is equal to, I can take R common, so 1 plus 1 upon RE. I can solve on the right hand side. Therefore, 1 is equal to R times, I can take the LCM. This implies 1 upon R. I take R here in the denominator. 1 upon R is equal to RE plus 1 by RE, which implies my R is equal to RE upon RE plus 1. And this is exactly equal to the critical level of interest rate RC. So I can say, therefore, my critical interest rate RC is equal to RE upon RE plus 1. Okay, so hoping students have understood this. And we can say that when my actual interest rate exceeds the critical level, so I can now write this. I can write observation. When R is more than RE upon RE plus 1, which is nothing but my critical level of interest rate, this implies E is greater than 0. This implies all my wealth is in the form of bonds. And demand for money is equal to 0. Demand for real money balances. M by P denotes what? M by P denotes demand for real money balance. Real money is nothing but nominal money divided by the price level. We have done this in our introductory macroeconomics course. Okay. Second observation, when R falls below the critical level, this is my critical level. In this particular case, it implies E is less than 0. So all my wealth is in the form of money, and demand for bonds is equal to 0. I'm holding all my wealth in the form of money in case 2. Demand for bonds is 0. Okay, and then third observation, when my R is exactly equal to the critical level, which is nothing but RC. In this particular case, E is exactly equal to 0. So I can say that my demand for money and demand for bonds lies between 0 and W. I'm going to hold combinations of, so when E is exactly equal to 0, you can also say that some part will be held as money, some part will be held as bonds. That means in the last case, the individual is either only going to hold money or only bonds or some combination of money and bonds. So both demand for real money balances and demand for bonds is going to lie between 0 and W, including 0 and W. So we are now in a position to draw a diagram which pretty much derives our demand for money. So on the horizontal axis, we measure demand for real money balances. On the vertical axis, we measure R, and we have the critical level of interest rate RC, which is equal to RE upon RE plus 1. When your R is above RC, when R is greater than RC, you're only going to hold bonds. So your money is 0. This is nothing but demand for real money balance. That is equal to 0. This is your wealth. Liquid wealth, I can say, to be more exact. Okay. When R is exactly equal to RC, you either hold only money or only bonds or some combination of them. So your demand for real money balances will lie on the horizontal segment, because when R is exactly equal to RC, either you will not hold money or you will only hold money or some combination in between. And in this particular segment, when R is less than RC, in this particular case, you are only going to hold money. When R falls below the critical level, you are only going to hold money. Only money means your demand for real money balance is exactly equals to the. So clearly you can see that this is our money demand function. This is our money demand function. When R is equal to RC, when R is greater than RC, demand for real money balances is zero and all your wealth is in the form of bonds. All your wealth is in the form of bonds. But in this particular case, all your wealth is in the form of money balances and bonds are equal to zero. So hoping all students have understood this. Okay, so I can come to the lecture note now and I can show all students what we have done. So today's lecture, primarily we started with this topic, regressive expectations model. Okay, we had done some part in the previous lecture. We had done this equation. Market rate of return is equal to yield divided by the price of bond. Therefore, price of bond is yield divided by the market rate of return. Expression for the capital gain. Put the value of PBE and P in this. You get expected percentage capital gain as R upon RE minus 1. Total rate of return E is equal to R plus G, R plus R upon RE minus 1. We have also derived on the whiteboard the individual's demand for money under the regressive expectation model. And what we have learned is that when E is greater than 0, the individual will put his liquid wealth in the form of bonds. If E is less than 0, he will put his liquid wealth in the form of money. When E is equal to 0, he is indifferent between holding its wealth in the form of money and bonds. And then we made this assumption, guys, that under the regressive expectation model, each individual or person is assumed to have an expected interest rate RE corresponding to some normal long run average rate. If the actual rate rises above the long run expectation, her expectations are regressive. She expects the rate to fall back. When the actual rises, she should, if her expectations were progressive, and if the actual interest rate went up, she would have expected the interest rate to rise in the future. That was progressive because you are moving in the same direction of actual. But in this particular case, when actual went up, she expects in the future the actual interest rate to fall back. That means expectations are regressive in nature. Okay, and again, guys, I forgot to write this point on the whiteboard. This is very important point. This point is telling us that we assume that her expected long run rate does not change with the change in the current market conditions. So this point is telling us that the long run average interest rate does not depend on current market interest. I forgot to mention this point on the whiteboard, so all students can look at this point from the lecture note. Okay, the long run average interest rate is not depending upon the current market rate of interest, and every individual is going to have its own expected interest rate corresponding to the long run average interest rate in the economy. Okay, so clearly all students can see now we have derived the critical level of market rate. The critical level RC is that level of interest rate which makes E exactly equal to 0. Now when R is greater than RC, when the actual interest rate exceeds the critical level, returns from holding bonds exceeds the returns from holding money. So we expect her to hold all her liquid wealth in the form of bonds. When R is less than RC, returns from holding bonds is less than the returns from holding money. We expect her to hold all her liquid wealth in the form of money. When R is equal to RC, you can clearly see in this particular case, E is equal to 0. This is nothing but my expression for E. I plug it equal to 0. I solve for the critical level of interest rate. I get my critical level of interest rate as RE upon RE plus 1. And you can clearly see in this particular segment, R is greater than RC. So all my liquid wealth is in the form of bonds, and my demand for real money balances is 0. When R is exactly equal to RC, the individual is on the horizontal portion where she can hold 0 money or all her money in the form of all her wealth in the form of money, or some combination in between. And in this particular segment, R is less than RC. So individual is going to hold all her wealth in the form of money, and demand for bonds decreases. Okay, so hoping students have understood this. Now let's move forward. Let me come back to the whiteboard now. Let's go into the further depth now. So till now we had assumed that the individual has a given expected interest rate. The individual has a given expected interest rate RE that is not sensitive. Or I can say does not depend upon changes in the current market rate R. Whatever analysis we have done till now, we said that every individual has its own RE, but we never said that RE depends on R. We were simply assuming that every individual is going to have its own expected rate of interest, expected rate of return in the market, and that is going to correspond to some long run average rate. We never said that RE is going to depend on R. But now, suppose the expected rate of return on the bond is some function of the actual rate of return today, with the sign of the derivative being positive. That means if the current market rate of return goes up, individuals also revise their expectations of the future market rate of return upwards. Okay, now you should not students should not confuse this with regressive expectation. Remember, I am once again repeating what is meant by regressive expectation in our model. It simply means that when the actual rate of return goes above the long run average, individual expects that in the future that actual rate of return is going to fall back to the long run average. That was regressive. But what is this telling you? This is telling you that till now we had assumed that the expected rate of return does not depend upon the actual rate of return. But now let's move to a more realistic case where your expected rate of return depends upon the actual rate of return today. And if the actual rate of return goes up, you also expect the rate of return in the future also to go up. But we are not talking about long run average here. The students should not get confused between two concepts. Okay, so now you can clearly see now what is my critical. So I can say, therefore, our equation for the critical interest rate was RC, which is equal to RE upon 1 plus RE. But guys, what is RE? Under the assumption that the expected interest rate depends upon the actual interest rate, I can write RE is nothing but f of R upon 1 plus f of R. And this I can call as another function h of R for simplicity. H of R is nothing but f of R upon 1 plus f of R. Okay, I am writing one point to make it clear to all students. Please note, I am making 2 points. One point is individual has regressive expectations. Individual has regressive expectations in the sense that if the actual R goes above the long run average, the individual expects R to fall back to the long run average in the future. Okay, this is individual having regressive expectation. This is one concept. Another concept is, so I can write another concept is point 2, that now the expected R, that is RE, depends on the actual R. Expected R depends on the actual R. When R goes up, individual expects the expected rate of return also to go up. Point 1 and point 2 are completely different concepts. So I can write point 1 and point 2 are completely different. They are not the same. So students should not get confused. I am again repeating, students should not get confused. You should not think that, sir, you have written f dash as positive. That means when R goes up, R is also going up. So how regressive? It should be progressive. No. Regressive is concerned with comparison of the actual R with the long run average. Regressive is nothing to do with comparison of RE with R. Okay, and this is another point 2 is another assumption we are making, that from now onwards, instead of assuming RE to be completely independent, let RE depend on the actual rate of return R. When the actual rate of return R goes up, individuals also revise their expectations of the interest rate. So RE is also expected to go up. Okay, so now let's quickly plot the relationship between R and RC. Okay, so I erase the initial part now. I erase the initial part and let's quickly plot the relationship between the two. Okay, so we can quickly plot the relationship. Okay, so this is R, this is RC. Okay, and RC is nothing but some function of R. Now guys, suppose this is my 45-degree line. On the 45-degree line, R is equal to RC. Tan 45 is equal to 1. All of us know. Whenever you are on the 45-degree line, horizontal and vertical points are all the same. So this is the line when R is exactly equal to RC. Now, let us see that H of R, will it have a slope more than 1, less than 1, or equal to 1? Because a 45-degree line always has a slope exactly equal to 1, right? Because tan 45 is 1. Slope is nothing but tan theta. The angle here is 45, so tan 45 is 1. But what will be the slope of H of R, given the assumptions we have made? So can we quickly differentiate H of R to find the slope? Let's do that. So I erase this particular part now. And let's differentiate H of R once. So erasing this particular part. Okay. So our H of R is nothing but RC, which is nothing but, what was it, guys? F of R upon 1 plus F of R. Now, before calculating the slope, suppose we assume that H of R slope is less than 1. I am not calculating the slope. I will be calculating it in a few minutes. Suppose I assume that h of r line is flatter. This is my h of r line. You can clearly see that the slope of this line is less than 1. Why? Because it's flatter than the 45-degree line. So slope is less than 1. Okay. So guys, you can see, look at this actual rate of interest R naught. You can clearly see that at R equal to R naught, actual R is exactly equal to the critical level, because this point also lies on the 45-degree line. So at when R is equal to R naught, R is also equal to RC. Okay. And when R is equal to RC, you can clearly see that individual is indifferent between, remember, when R is equal to RC, individual is indifferent between holding well in the form of money or bonds. When R is equal to R0, R is also equal to RC. You can clearly see at this particular point, R and RC are exactly equal, because this lies on the 45-degree line also. And on the 45-degree line, R is equal to RC. And when R is equal to RC, when actual is equal to the critical level of interest rate, we can say that individual is indifferent between holding wealth in the form of money or bonds. On the other hand, so this gives us, basically when the individual is indifferent, it gives us the horizontal portion of the money demand curve, which we derived in the lecture today. Horizontal portion of the money demand curve. So I'm drawing another small diagram here. Money demand. Okay, this is R, and we had derived this money demand curve, guys, in today's lecture. This is W. This is R equal to RC. This is nothing but the horizontal portion of the money demand curve. Okay. When R is greater than R0, suppose I have a R here. Suppose this is my actual interest rate, it's greater than R0. Now, guys, corresponding to it, my RC is this much given by H of R. This is my RC. But when will R would have been equal to RC? R would have been equal to RC here. So this should have been my RC for it to be equal to R. But my actual RC is this. So I can say at R greater than R0, R is greater than RC. Because guys, at this R equal to RC would have occurred at this point. But my actual RC is not this. My actual RC is given by this. So that means R is greater than RC. Because for RC to have been equal to R, you should have been at this point. But you are not at this point. You are at this point. So for your given horizontal intercept, your vertical intercept for equality should have been this much, but it's only this much. So R is greater than RC. So this implies the individual, all of us know when R is greater than RC, the individual will hold all its wealth in the form of bonds. When actual exceeds the critical interest rate, individual holds all its wealth in the form of bonds. You are on this particular portion where your demand for money is equal to 0. And then guys, you can clearly see that at R less than R naught, when instead of here guys, suppose you are here. Suppose you are here when R is less than R naught. Now guys, at this, what is your actual RC? At this, your actual RC is this much. But the RC required for equality should be this much. That means your RC is more than what is required for equality. So I can say R is less than RC. When your actual rate of return falls below R naught, then at this level of market rate of return, for equality to happen, your RC should have been this much. But your actual RC is given by the H of R line, which is this much. So for R less than R naught, R is also less than RC. When R is less than RC, individual will hold all its wealth in the form of money. When your actual rate of interest falls below the critical level, then individual is going to hold all its wealth in the form of money. So this gives me the blue portion. So this gives me the blue portion. The second one gives me the red portion. And the first one is going to give me the black portion. So black portion, red portion, and blue portion. Okay, so you can clearly see we are getting the same money demand curve even under the assumption that RE is a function of R. We had made this assumption right now before doing this diagram. We said that let expected rate of return depend upon the actual. Even when I make this assumption, I still get the same money demand. And now students must be wondering that, sir, how have you taken the slope as less than 1? So let's look at that as well. So H dash R. Can I apply quotient rule of differentiation here? I have to differentiate with respect to R. All of us know the quotient rule from mathematics. Okay. Denominator into numerator का derivative with respect to R minus numerator into denominator का derivative with respect to R divided by denominator square. This is our H dash R. I need to show under what conditions will H dash R be less than 1, because we assume that H of R has a slope which is less than 1. So guys, if I further solve this, so my H dash R will be, I can open up the brackets, F dash R into 1 is F dash R plus F of R into F dash R minus F of R into F dash R divided by 1 plus F of R cos square. This cancels out with this. What do I get as H dash R? So if I erase this particular part now, I'm erasing the portion on the right hand side of the screen. Okay, so we can now write the observation. Therefore, my H dash R is F dash R upon 1 plus F of R cos square. And guys, what is F of R? F of R is equal to RE. So I can write H dash R is equal to F dash R upon 1 plus RE cos square. Since RE is nothing but function of R. Now guys, you can see my denominator is always positive. If you look at the denominator, which is 1 plus RE cos square, it is not only positive, guys, it's even greater than 1. Since RE is positive, your expected rate of return, you can't expect a negative rate of return. Your expected rate of return RE is positive. So 1 plus something is greater than 1. Okay. So denominator is greater than 1. So guys, if my denominator is greater than 1, for the whole term to be less than 1, because we want H dash R to be less than 1. So I can write, therefore, for H dash R to be less than 1, my numerator should be less than 1. It's like saying, if I come to the left hand side, let me explain this in a more proper way. Suppose I have numerator by denominator. Okay. My denominator is greater than 1. Why? Because it's 1 plus RE ka square. 1 plus RE ka square is greater than 1. So for my whole expression to be less than 1, my numerator must be less than 1. My numerator must be less than 1. Only then my numerator, that means my numerator should be a fraction. Only when the numerator is a fraction, even if my denominator is greater than 1, my numerator by denominator whole thing will be less than 1. So guys, you can now see f dash r was what? F dash r was nothing but dre by dr. Because guys, look at this, re is a function of r. So if I differentiate re with respect to r, it's nothing but f dash r. So f dash r, which is dre by dr, is less than 1, which implies that when the actual rate of return goes up, re increases, but by less than the increase in r. This is another way of saying that expectations are regressive. This is another way of saying expectations are regressive, because when r goes up, re goes up, but by less than the increase in r. That means when the actual market rate of return today goes up, individuals are going to increase their expectations, but by less than the actual. That is why the expectations are regressive. That is why they are regressive, because your expected R is moving up slowly as compared to the actual increase in R. Okay, so you can clearly see that. So we can say that expectations are sufficiently regressive in the sense that the current market rate causes smaller changes in the expected market rate. Okay, so that means that for this particular diagram to hold true, that means for h of r to have a slope of less than 1, expectations must be regressive. That means when the actual rate of return today goes up, expected rate of return also goes up, but by less than the actual. Okay, so students, this is where I intend to stop. If I come to the lecture note quickly, okay, this is from where we started discussing. We discussed on the whiteboard. Okay, we took re as a function of r, where both share a positive relationship. Okay, rc is nothing but re upon 1 plus re. Now re is nothing but f of r, so I put the value here. This diagram has been properly discussed on the whiteboard. Okay, and you can clearly see we have taken h of r as flatter than the 45-degree line. That means h dash has been assumed to be less than 1. And then on the whiteboard, we have discussed all the explanation properly. And we have also seen the condition under which h dash is less than 1. I have done the whole algebra in my lecture note also, which I have done on the whiteboard as well for all students. Okay, and you can clearly see that expectations must be sufficiently regressive, that movements in the current market rate, which is r, cause smaller movements in the expected rate re. That means the denominator is greater than 1. So for the whole term to be less than 1, my numerator should be less than 1. And f dash r is nothing but dre by dr, which is less than 1. That means when r goes up, re goes up, but by less than the increase in r. Okay, so this is where we intend to stop. The objective of this lecture was to go deeper into the regressive expectation model and derive the money demand. We have derived the money demand curve without making the assumption of r equal to function of re. So when we had derived this money demand curve, re was independent. When we derived this money demand curve, re was independent. It was not depending on r. But when we make the assumption of re being a function of r, then also this diagram is going to give us the same money demand, which is this. That means even when I make the assumption that the expected rate of return depends on the actual, I get the same money demand, which we have discussed on the whiteboard. Okay, so hoping all students have understood this. So look at this. When h dash is less than 1, then individual's demand for money function is going to look like the same as diagram 1 when r is a function of r. What is diagram 1? This is my diagram 1. So when you make the assumption that RE is independent, it does not depend on any factor, then also you get the same money demand curve. When you make the assumption that RE depends on R, then also you get the same money demand curve. So this is where I stop. In the next lecture of money demand theory, what are we going to do? We are going to look at the aggregate money demand. We have derived today the individual money demand function. In the next lecture of money demand theory, we are going to derive the aggregate demand for money function with regressive expectations. Okay, so I stop in this particular lecture. I hope all students have enjoyed this lecture. Any doubt, you can unmute your mic and ask, or call up or mail me your doubts at divineschoolofeconomics@gmail.com. So this is where I stop in this lecture.